Hello folks, and welcome to the channel, or welcome back to the channel. And in this video we're going to do something completely different. It is not going to be very greasy or very labor intensive. We're going to register the AFR values on a Mini while we're driving it, and the whole purpose for that is to be able to tune the carburetor. Now we are not going to tune the carburetor in this specific video, that will be later, but I'm going to show you on how you can capture the AFR values from an AFR gauge, on how you can import it into a graph. And we will be doing this by driving the car in different regimes: idling, acceleration, wide open, and cruising. And along all these moments I'm going to capture the data of the AFR gauge. You've seen me installing the AFR gauge some time ago, and if you want to see how that goes, please refer to that video. But in this video we're going to actually use that gauge and use that data. And at the end of the video we're going to analyze what's happening with this carburetor on this Mini. And the method I'm going to show you is something that everybody can do if you have an AFR gauge. You don't need expensive software to analyze anything, and you'll see that during this video. And we're going to practice this on a classic Mini with a SU HIF-44 carburetor, but it's applicable to any classic car with a carburetor. It doesn't really matter if it's an SU or something else, or a Lorto, or even a Weber. It doesn't really matter. The analysis will be a little bit different of what the cause could be for misalignment, of misadjustment, or mistuning. And I think here a critical word fell: tuning. A lot of people refer to tuning a carburetor, but in fact what they really mean is adjusting the carburetor, because all what they do is adjust the idle mixture with the idle mixture screw and the idle RPMs, and that's about all they do. And that to me is not tuning. But tuning a carburetor is really all about getting it fit for purpose, and it means changing the jets, the air jets, the fuel jets, the emulsion tubes, the needles, all that to match it to your specific driving conditions. And you might have seen in my previous video that I talked a lot about the stoichiometric value, 14.7 parts of air versus 1 part of fuel, as the most optimum ratio for burning all the fuel. And that is still the case, and nothing has changed on that. However, there should be no misunderstanding that you don't want to maintain that stoichio value during acceleration. You might want to go to a 10:1 ratio, because you need more fuel for acceleration. Especially for wide open, you're probably going to be sitting at 10:1. And the same thing is true then for cruising, and even for idle. Maybe your engine isn't running all that well on a 14.7:1 ratio on idle. Maybe you want to give it a little bit more richness. So you're always going to have these small little differences on that. So and that's why it's so important to test drive the car and to be able to measure the AFR while you're doing so. Of course, if you have lots of money, you can take it to a dyno, and all these things can be tested on a dyno, but you don't need to go to a dyno. If you have an AFR gauge and you can drive the car on the road, you can test it yourself. If you understand the carburetor, you can analyze the curves that you get from the AFR gauge, and then you can actually start working on the carburetor. We're going to do this on this HIF-44 SU carburetor, not in this video, because first of all I need to analyze it. So enough talk, so now let's get on with what we're going to need, and then we're going to install it on the car and we're going to start running it. Some people claim that looking at the spark plugs and the state of the spark plugs tell you all about the state of the engine. Well, there is some truth to it, but it's by certainly no means to actually verify how good the carburetor performs and how good the tuning is of the carburetor. It tells you that in average you're running too rich or you're running too lean based on that color, and it's all about what it tells you. But it doesn't tell you anything about acceleration. It doesn't say anything about cruising. It doesn't say anything about wide open or even idle. So yes, using a spark plug, it's an indication, but certainly not a means to tune your carburetor. In the previous video we installed the AFR gauge and cabled it up to the monitoring port or the logging port. And I installed the DB9 connector for logging the data into the place where the ashtray used to be. So now I can just connect my cable to that port. And that's the port where I'm going to connect my laptop or my Mac to start logging the data. To do this job, you're going to need a couple of tools, but you don't need a whole bunch of tools. You're going to need a Windows laptop or a Mac. It doesn't really matter. I'm using a Mac because that's what I like and that's what I have. And you're going to need a cable. Now, most laptops or Macs today don't have serial connections anymore. And this is a serial connection. It's a DB9. And you don't find these plugs on your laptops anymore. So what you typically find is a USB connector. And you can get these cables. These are converter cables from USB to RS-232 or USB to serial. They're very cheap. They run about €2, $2 a piece. And they're very helpful, and this is what you're going to need. So we're going to hook up a USB port on the laptop with this cable to the monitoring port of the AFR gauge. This is the circuit diagram of the actual AEM gauge, but it could as well be another gauge, and it might be a little bit different. You have one big connector here, which is going to your sensor, and I've shown you that on how all that is installed in my previous video. And then you have another connector right here, which is already hooked up to the gauge itself, and it comes out with a whole bunch of wires. Now, to record any data from that, you need to have a serial connection, and the serial connection terminates typically on a DB9 connector. That doesn't come with it. You have to get this from a hardware store or a computer store or electronics component store. They are very cheap. I installed the DB9 connector, in my case a female one, on my dashboard, and I have a cable going from that one to my laptop or my Mac. Removable, of course, and that's where the two connectors plug together. The actual DB9 needs only two signals. It needs a pin number 2, and this is pin number 2, and these pins are numbered actually on the connector themselves, and that's where you're going to get the data from the actual gauge itself. And of course, you're also going to need another connector on that, which is the ground, which is pin number 5 on the DB9, and that's all you're going to need to it. And over those two wires, you will now be able to receive the AFR readings from the gauge as soon as the gauge is running. You also will need your laptop, because you're going to use your laptop or your Mac to log all the data. And you're going to need a couple of applications. You're going to need a grapher application, and you're going to need a terminal application that is communicating with the serial port and saving the data. These applications are very cheap. In fact, they are for free in most cases, or even embedded in your operating system of your specific device. I'm going to give you in a few minutes a couple of examples on how I'm doing it, and then you can figure it out for yourself if you have something similar or you want to use something else. It's easy, very easy to do. Before we can start recording the values that have been transmitted by the gauge to our application, be it on a Mac or be it on a laptop, we'll have to set the communications application to a very specific baud rate, or the speed of that communication, the amount of data bits, the parity bit, and of course the stop bits. You need to set this because otherwise your application will not understand what the gauge is sending you. Now that might depend a bit from gauge to gauge, but for this specific gauge it is 9600, 8 data bits, no parity, and 1 stop bit. And now the application, or the terminal, or whatever you want to call it, can now receive the data from the gauge as soon as the gauge is powered on. But keep in mind that the format in which we're going to get the AFR readings is something like this. And you can see that 14.7, that's going to be the actual AFR reading of that moment in time. And you're going to get a whole bunch of readings, one after the other. But that is followed by a carriage return and a line feed. And a carriage return and a line feed is something we'll have to remove later in a text editor before we go into import that log file into our Excel spreadsheet or into a grapher tool. Now let's have a look on our terminal program on how we're going to set that one up. There are many applications that are available to be used as a terminal for serial communications. I'm using what we call a serial app on my Mac, but on a Windows PC you will find as well multiple applications that can do exactly the same. So it doesn't really matter as long as the application can communicate over the serial port. So let me open this up and then we'll see what happens. So when I open it up, you can see immediately that what I see here, there is a USB 2 port, and that's the port I'm going to use. That's where my cable is plugged in. So I'm going to select it, and then we open it up. If I remove my cable, you will see that it will say disconnected. See that? Right here, it says disconnected. If I put my cable back up, it will say connected. Right, now it's important to set the terminal to the proper line speed and line coding as we've seen before on the gauge itself, because that's what the setting is on the gauge. So we're going to go to settings, and then we go to line coding. And here you would set the baud rate that you would desire. Now in our case, we know it's 9600, so let's select that one. 8 data bits, no parity, 1 stop bit, and you don't need no flow control at all, because we only have 2 wires, a ground and a receive data. And that's about it. There's nothing more we need to do on this. And now we are about ready. The next thing we're going to do is to log all what it's incoming. So we start the log, and now it's going to save that anything that comes in now from the gauge will be stored on the log file on your PC or laptop. And that's it. So now we could crank up the engine basically and start running. So we've got the laptop and I turned it on already. So I'm going to hook up my USB port and then hook it up to my monitoring point of my AFR gauge. I'm sorry, I should wear my glasses because without glasses I don't see nothing. So that's one side which is hooked up, and I should hook up the second part now to the probe here, and that should go like this. There we go. It's now connected. So now I can start my monitoring program, which is this serial application. I'm going to start to log. All right, so that's all set up and ready to go. Now I'm going to crank up the engine. The gauge will warm up first. Now, as soon as I turn on the power, you see all the 9s appearing on the screen. That is the gauge warming up. So it's going to scroll through until it's completed its warming up phase. So as you can see, it's still rolling through. Now it's done. So if I start now the engine, you will see actually the values coming up on the screen. So I'm going to start it. And now you see the numbers scrolling on the screen, and these are the different AFR values that we have. And as you can see, this is now running a little bit rich, but it varies a bit. All right. So let's shut it down and take it for a test spin. I'm going to take the car for a test run so we can record all the values. I'm going to let it set idle. I'm going to start the log. Then I will accelerate through all the gears 1, 2, 3, and 4. Then I will cruise a bit, and then I do a wide open. And then I let the throttle go. And that's going to be the sequence of testing. The weather is terrible. It rains like hell. Okay, it is what it is, and we'll see how it goes. Once we are back, we'll then look at the actual figures, and we graph it out on a graph and see how good or how bad it is. Right, so I'm going to start recording now, and I'm going to set up the laptop, and the weather is awful, but that's okay. The engine is warmed up, or almost. Take off. I'm going to accelerate through the gears, and then we'll see what it does for us. Go that's it. So we are back from our test ride, and we took the car through the different stages. We had it on idle, we had acceleration, first, second, third, fourth gear, then we did a wide open, and then we let the throttle go. I would have loved to go to an uphill climb, but I didn't do it this time. The weather is just too bad to go there, but I'll do that next time. But we got everything recorded, so my file is now here. And now I'm going to change the file name so then I can process it. So let me show you on how that works. Now that we have a log file stored on our desktop by the gauge, as soon as we stopped, of course, logging, we can't really use the .log extension, so we'll have to rename that file. Doesn't matter, but let's say we're going to rename it to AFR1.txt. AFR.txt. I think that should be good enough. And now we have actually a text file. Now that the file name is changed, now we're going to convert it a bit, so we don't have the line feeds and carriage returns anymore. We have it all nicely separated with commas. That will make it easier for importation into an Excel spreadsheet or a grapher tool. So let me do that. If we open up our text file, which is actually the log file, you will see all the AFR values one after the other. And that format is not all that suitable for importing it as a CSV file into any grapher tool or even in Excel. So therefore we have to change that. We will remove all the line feeds and carriage return to a comma so we can create a CSV file. We also have some other information on the top here that we don't need, so I'm going to delete this. And now I'm going to replace the line feed and carriage return in this document. So I'm going to go to an edit, I will go to find and replace, and I will be looking for carriage return. And you can find this by a pattern, and here's the pattern, and then you go for line break or carriage return. But I don't need it there, of course. I needed it on the top one, and I'm going to replace it with a comma. Oops, that's not a comma, that is a comma. And I'm going to replace them all. And there you go. Now we have the proper format, the AFR value, separated with commas. And now we can import this very easily into a spreadsheet or a grapher. So I'm going to open up a spreadsheet now so I can show you on how that goes. So we open up an Excel spreadsheet, and we're going to open it up from our desktop where we had our AFR text file. I'm going to open that up, and here it says it already that it's delimited. It has seen it already with commas. I'm just going to say next. The separation is a comma. I'm going to say next. It's general, and then we'll finish it. And now we should have that in our spreadsheet. See, now we have all these columns, and now we can actually use this into a graph if you wanted to use the graphs from Excel. And now all that is done, so now I can import it into the grapher tool. Let's import the file and then see. So I will open up this grapher, and this is a grapher that comes for free. It's called the ZGrapher. So I'm going to import the data. Here you have our file with all our values that we measured. So now I'm going to open up this grapher, which I have over here. And this is a free grapher, by the way. It's an app for your Mac. And I'm going to import the data from that file. And here it is. So let's open that up. And immediately you will see that the data comes in. And now you can actually see the curve when we were accelerating the different gears, when we were kind of cruising along. We did that for a while, and then we went actually wide open, and you can see what happens in wide open. We actually go very lean, and then we go back down to more rich. But as you can see, this whole curve doesn't make a lot of sense for a good calibrated carburetor. You can see it at the start, we were running a bit on idle, in fact quite lean on idle, around 16. Then we took off, and as soon as we depressed the throttle, you could see that we went extremely lean. And then after that, the throttle reacted to it, or the carburetor reacted to it. We got a little bit of a richer mixture, 12.9, and then it was kind of, and we were in first gear accelerating, and now you can see we had the short acceleration here, but then it really became lean again, and then we actually shifted up again to the second gear. We went a bit rich again, but then it built up lean again, and we moved to third gear, and then eventually we moved up to the fourth gear, and again it was very hesitating, the car, to accelerate each time, and that is obviously because of this very lean area here. It picks up after that, so it's a bit of reluctance, and then it picks up with a richer mixture, and then we started to accelerate a bit, and then we started to cruise for a while, which is kind of alright. It's kind of like where it should be, 14.7 in average. It's going up and down a bit, so it shouldn't be doing that really. This probably is indication that something is really not right with the carburetor. And then I decided to go wide open. Now, as soon as we decided to go wide open, you could see that, you know, although I floored the gas pedal, we went extremely lean, so the carburetor wasn't able to feed the fuel to the engine, not enough at all. But it recovered. It took a while of hesitance, and then it recovered shortly after that over in this point. But you can see how that is actually going up and down. So it is almost like the piston in the carburetor in the SU is actually opening up now, and then it drops down again and opens up again, and you know, it's like a yo-yo effect. So yeah, there is some issues with this. I'm gonna work now out this graph a bit more and mark the different zones for you, so you can actually see on how to interpret these graphs. So when we started the car, we saw some very lean mixture initially for picking up speed, and it wasn't good. Then we got a little bit of more rich mixture, and then it started climbing in again in the very lean area. And this symptom happened across all the shifts. So the second, the third, and even the fourth gear, there was always some form of reluctance to pick up speed. And then it actually happened shortly after that. And that's because of the lean mixture, as you can see on the graph. But once we were at cruising speed, things started to stabilize a bit, and you can see that in the blue curve. There we see the cruising curve, and that's kind of alright, but still there's a bit of oscillation, and I think this is all related to the same problem. But once I went to wide open, we again ended up in a very lean mixture initially, and then going to more rich, but then oscillating between very lean and rich, up and down. And the rich wasn't really all that rich, because I would have expected at least a 10-to-1 ratio. So there is something really wrong on that carburetor. Most likely on that damper something is wrong, or the needle, or the jet itself. And then when I backed off power, then I let the throttle go, then we ending up lean, which is okay, but that's about the only thing which is alright. So folks, we're nearing the end of this video, and you have seen on how you can capture the performance of your carburetor, how well or how badly it's tuned, with some very simple tools by a terminal on your laptop or your MacBook. Log in the files, and then using a grapher and a test ride, you can really see what's going on with your carburetor. And on this specific car, it wasn't very good. So in the next video, we're going to tune all this and make it better. So keep watching. Bye-bye.